See this? This is what $316 worth of shipping and handling costs looks like. So, we have got ourselves a brand new microscope in a box. So all my whining about using the video cam as a microscope is gonna have to stop by now, and I have a horrible feedback coming through somewhere. There we go. Right. So yeah, this pile of stuff was about $1,300 including shipping, and it comes out to like 1,200 euros after tax and everything, and we're going to be putting that together right now. So we've got a bunch of stuff. I don't even remember what I ordered due to shipping issues. It got stuck for a very long time, which made me a bit annoyed. But here is the paperwork. So we have one SM4NTP FRLP 7045 times simulfocal stereo zoom microscope. So this is the kind which has the third optical channel for the camera. And we have a fluorescent microscope ring light, which I don't really need, but the best kit available had that in there as well. We have the fancy dual arm boom, which I think is fancier than the one Louis Rossmann has, so that feels good to say. We have a cheapo camera VGA, and we have an 8-watt LED light as well. So this is the light we're going to be using primarily. It's a slightly fancier light than the others, so let's just get this party started and put this thing on the bench and start turning it into something that we might use. And I still have too much volume on my feedback there. There we go. Just a whisper. So the reason this was so expensive to ship is because this base is incredibly heavy. It's the whole packet was about 27.1 kilos, and that base is probably 20 alone. It's a huge cast iron thing. Paperwork. We don't care about that. I know how to use this. So, boxes of stuff. So let's just start by you're probably admiring my beautiful bum right now. My lovely sweatpants. So we probably want to go for a different camera angle, I think. But let's just do that after we have everything loaded up onto the bench, so you get to see what I'm actually doing. So, since I do have one of these at work, a slightly cheaper version, I have a reasonable idea as to how to assemble these, thankfully, else we'd be really going on an adventure. And here comes the fancy part, the microscope head itself. Can't really fit it anywhere. There we go, so let's get a better couple of angles going for you guys. Someone's saying audio is perfect, that's good, until I hit my mic pack by accident again and we go mute forever. Let's see if we can turn this into something serviceable. There we go. That's decent. Yeah, that's decent. And this camera can do like what? What on earth? Why? What have I managed to do with these cameras? I have no idea. Oh, I forgot it on the test scene. Whoops, that wasn't my intention. My whole big dramatic intro got all destroyed by that. So, we're supposed to be on that scene. Whoops. I suck. Why does it say we have like 5 views? I'd expect a few more. Oh well. Right, so this thing is out of frame. This is difficult. This workshop is shaped so tiny. So this thing is going to screw into our base. So it's a thick metal tube. And we have a screw there, so this should just go on that. So that's the basis for everything, and we have a tensioning screw in the bottom that we have to torque down slightly just to make sure this doesn't start twisting out as we use it, since we're obviously going to have a lot of horizontal movement on the microscope boom arm once we have it in service, but that feels really sturdy. Right, so the next part is going to be the slidey bit. So this is the fancy dual arm sliding mechanism. So we have a ball bearing, or like some slidey bearing thing in the top one, and the lower one is just poking through this piece here for balance. So that means this is going to be very sturdy. You can't torque and twist this at all, which I have learned to like. I have this at work as well, and I wouldn't want to live without it because it's very easy to knock your microscope head at an angle otherwise. I've noticed that this balancing thing does a lot of work when you have it reasonably mobile. So this goes on like so, and we probably want to bring this down a bit, something like that. I'm gonna lube all of this stuff up a bit after assembly as well, because it's my bench. My bench is leaning. Ha. This is better lubed up than for when I have at work. That one was a bit dicky to get to actually slide, so that's good. We do have a brake on this lever, so you turn this and it locks it in place. So I'll just put it something like that, and this is the microscope thing, which is dropping expensive pieces everywhere. Okay, this thing came off. I have no idea where that goes. Okay, this is coming apart. What have I done now? What's going on? Oh, right, yeah, I see now. So, this is like... Let's just get the close-up camera thing going. We'll do it like so, and we'll put this down a bit and zoom it all in. Something like that. So the way this works is you have a camera that's underexposing because it's a bad camera. So you have 2 of these metal inserts here, and they have a cutout there, which is gonna fit up against the metal rod which goes in there. So we need to have both of these in the right orientation, like so, with the faced side going down in there somehow, and the other one stuck in there horribly. This has not gone to plan. There we go. So we can we get this inside? We should be able to get this inside. There we go. So now we have these 2 metal pieces there, which are going to clamp onto the metal rod, and we have a handle which goes into those, which we can get on either side, which is very nice. Let's see, this one's going to be used on the left side, so we probably want to have this on the right side. I would imagine that's going to be most comfortable, but I know let's just do it on this side because that's the way they happen to go in. So we need to undo this enough to actually get it onto this piece. So now we have a great big dong hanging down from our microscope. Come on you go. Oh, I really need to undo these a lot. That's why the one came off, because you really need to undo these super hard, because you have this little recess back in here which they're supposed to go in. So, come on. There we go. Now I actually want this on the right side, so let's reconfigure our dong alignment pieces. So that goes on the other side. One of these is threaded, the other one's just a hole, so it's... Man, this echo is super annoying. But I need to have the echo, or else my audio can go out without me even noticing, and yeah, we know what that's like. Someone's asking, did you get it at Rossmann? No, I didn't, because I got it from Amscope directly. I'm assuming Amscope is cheaper than Rossmann. I didn't even know he sold microscopes. There we go. That's annoying. A nice thing about it, when we have this lever just pointing up like this, you can actually undo these and put them on the other side so they're pointing down and don't stab you in the eye. At least you have been able to do that in the past. No, you can't do it on this one. Well, that's annoying. The one I have at work, which is about 2 years old or so, you can actually reconfigure that, so that's annoying. I'm not happy with that. Oh well. Can't have everything in this world. So now we need to put our focusing rack onto our newly installed dong. So this is the part which holds the head, and you can see by turning this it moves up and down. So that's going to allow us to focus, and I like the way you adjust the tension of this is by just turning both of these in different directions. So if you really want it to be super sturdy, you can just make that super sturdy. Or you can have it very light, you can turn it down so light that it slides down on its own. So that goes on there. We tighten that down, and we install the end cap just to make sure it doesn't fall off if we accidentally undo that, potentially ruining our microscope head. So, well, that's annoying. How are we supposed to... So we can't quite tighten this properly without undoing this. That's annoying. That's annoying. So we just need to kind of get this past here. That's a bit of a design oopsie. But I guess they have pretty decently sized tolerances on all of these pieces, since they're basically friction clutches, all of them. In order to allow for reasonably smooth adjustments, you need to have big tolerances. There's like a couple of plastic pads in between here which grip onto this, and we can really just adjust this so it's sitting at any angle. So let's just do it reasonably straight, like so. And that's over quite tight, not quite as tight as I want it to be. Well, there we go. And that one's pretty tight as well. Yeah, this is not going to fall off. Right, so let's move to the exciting stuff, which is the microscope head itself. So this is the expensive part. You pay for shipping for the foot, you pay money for this. So this is the 7045 times try not know, what was it, simulfocal. Yes, simulfocal head. So we have 3 optical paths in this. At least I think that's how it works. Am I undoing the right thing? No, I don't think so. There. I think just the end, there we go. Just the end cap comes off. And that should reveal. Okay, we just have 2 optical paths going in here. I have no idea how they derive the 3rd one for the camera. What happens if one do this? I've never tried this. I don't know if you're supposed to take this off. Okay, that just makes it easier to check out the internals. That's very greasy in there. That's very greasy. You can see. Let's just make that a bit bigger. You can see the mechanism for zooming in there, if that's going to ever focus. That's a lot of grease. This feels very good. Very smooth motion on that. Seems to be an old plastic mechanism there, but nothing wrong with plastic as long as it's done right, and they've definitely greased it up properly. Looks like black moly grease actually. Maybe. No, it's just for plastic being black. It's just normal grease, but you can at least easily grease that up yourself if it ever dries up. It's pretty recessed in there though. There we go. And this just plops in here. And you have a tightening screw down here for tightening this in place. I actually like having this loose so you can just angle it however you want to. And I don't think it's really meant to do that, but I like having it that way. Right, that ought to be most of the important pieces. We have some, oh yeah, we have the eyepieces in these boxes. So, they look like that. Let's just have a quick gander of those on the close-up camera. There we go. That's the completely out of focus. What's that? WF10X/20. 10 times eyepiece. We just have the tiny rubber thing on there. Like it seems kind of random which of the Amscope eyepieces have the big rubber things which like extend about a centimetre or so out, and which have the small ones. I think they're probably fine either way, but obviously the big ones are going to block out more peripheral light. I've never used the tiny ones, we just have the big ones at work, so I don't know what that's going to be like. So let's try and get these guys installed. They should just plop in there. A nice thing about this microscope head compared to the old one at work is this one actually has attachment screws for these. The old head does not have any attachment screws for the eyepieces, and that actually means that you can brush your hand past the eyepiece, like by just there's a little friction of the metal that I've actually by accident just brushed past and almost pulled the eyepiece out, so it would plop out and shatter into a million pieces if it went all the way out. So these screws are a very nice improvement over what we saw last. So which piece of this? It's rotates. Let's just put all the text facing up, like so. That looks nice. and tighten them down. I usually just have these. Well, do we want them? We'll probably want them set to 0, so this is like a glasses thing. 0, 0. There we go. That's that. Now the final thing we have, aside from the light, which actually goes onto there, is the camera, which I've taken out and actually installed the drivers for. So we should be able to just fire this up and have a look at something. Someone in chat is asking, did Santa stop by? No, Santa is very expensive this year. I actually have no idea how I'm supposed to make money off of this thing. I'm hoping it'll pay for itself within like 10 years. But for the time being, I actually don't have a business model going, which is going to make this thing pay for itself. So if anyone wants any like microsurgery done on some electronics, you feel free to send it my way and pay money for it. Right, so we're moving on to the light now. So there's the LED ring light, which is going to be the main light. We're going to be installing that. So this is a pretty vanilla ring light thing. I think it's rated 8 watts, and I got this over the other ones because it has the dimmer on the actual light itself. Most of the lights, all the cheaper ones, have a dimmer on the power supply, and I have one of those at work, and it's horrible having to reach to the power supply to adjust like the dimming somewhere behind the microscope, because you're always adjusting your brightness level depending on what you're working on and your working distance and stuff like that. So that's nice. We have, oh, it actually comes with like a ring thingy to mount the light onto. That's very welcome. I didn't get that with the cheap light I have at work. That's not an Amscope light though, so I don't know if Amscope's cheaper lights come with that. They probably come with this ring as well. It's not very this plastic ring is not an expensive piece. I can tell you that. It feels really horrible and plasticky, but it's probably better than just mounting it straight onto the metal there, because the plastic can flex a bit, so we get better adhesion from these triple screws. So we probably want this to be reasonably evenly spaced on all sides. Lots of screwing. We should probably take this light apart at some point just to see what makes it tick. It's probably a very basic light. Let's get it reasonably straight on there. Where's the power plug? The power plug's on the back, so how's that even going to work out? Okay, we can't have that facing straight back. That's a bit annoying. We're going to have this facing to the left. Something like this, because else the plug is just going to get horribly in the way. That's not a super nice design. Generally, I don't like this big lump they have on it. That's a bit dodgy. Ah, yeah. Now we get into the fun part. I paid $30 for a 230 volt conversion, and that's what they shipped me. A def adapter. So yeah, I'm not happy with that. And what's even more fun is this I think this is the fluorescent light thing. I'm not sure if they even bothered giving me a 230 volt fluorescent light, because the fluorescent light also has an American plug on it. It says 110 volts there, so we're gonna have a bit of fun plugging this in and seeing if it goes up in smoke. The lights are rated differently, but there's no rating on the lights at all. In fact, these lights look really low quality. So yeah, I'm not impressed by this at all. This is not fine for a $30 to 30 volt conversion. But yeah, I'm betting this, where the hell is the camera pointed? I'm betting this thing is just gonna draw like 40 watts and go up in smoke. But I could be wrong. At least we get another ring with it. Where the hell is that camera pointed? There we go, another ring, so we'll have a spare one for that at least. But yeah, they're gonna get an angry email from me if this light goes up in smoke. In fact, let's just not even, this is just, like the power supply for the LED light is just a standard 12 volt half an amp thing. It is UL listed. We should probably take this apart at some point as well. Maybe we'll take it apart under a microscope. But yeah, not too impressed. It is universal voltage though, so we can actually use it. So let's try the light out with the included def adapter, of course. Ugh. Could they not, for products this expensive, at least stock proper 230 volt power supplies? These are not expensive. Right, so this works. Dims down to 0. And quite focused. Wi-Fi, just what you want. Don't mind this at all. It's not flickery at all. That's probably some like 555 timer based dimmer this or something of the sort. But yeah, I don't mind this. Better quality LEDs than in the cheaper one I have at work, that's for sure. So yeah, I guess that works. Now I'm going to just take a look at this, see if we can see anything, and in a moment we're going to fire off the camera. Oh no, actually let's not be greedy. Let's give you guys prime time as well. So there's the camera. Yeah, probably want to look at that as well. I'm hoping I'm not going to kill OBS Studio by disconnecting that, but we need to do that because I can see it's a thread mount. We need to twist in order to get it in. So the camera I got is an Amscope MU035 0.3 megapixel Aptina color CMOS camera, as well as the Amscope FMA 037 adapter. And this comes with a couple of extra ring adapters that to fit it into the iPods, but we shouldn't need that, I don't think. And these are really fancy if we look inside. Like I thought this was just going to be your standard issue webcam sensor, but that sensor is a lot fancier than your average webcam, a lot larger as well. And the 2 megapixel or 1.3 megapixel cameras aren't much more expensive than this, but they have inferior light ratings. This one is supposedly better at low light because it's got larger pixels, so I'm hoping we're going to be able to use that. And also I'm cheap, of course, so I wouldn't pay extra. So I'm not sure how this is going to go in. There's a thread in the bottom there. There's an external thread there. Does this undo? How do you? That's obviously not right. How the hell do you get this thing on? Is this only for the viewports? Do we like just not use this adapter thing? To, like, is that how it's supposed to work? No. That's obviously wrong. Perhaps we'll have to read the instructions for this. This is a bit weird. Did we get instructions? Where's the camera box? There are no instructions in the box, so I'm just gonna have to look on the PC. That's a bit annoying. I thought it would just fit straight, fit right into the hole. How are we supposed to use this? View help manual. Amscope English help.pdf. I don't think I have monitor capture right now. Okay, so that I've just got a manual for the camera software. Doesn't say how to mechanically install the camera. Well, that's great. Does it seriously not say? The software you get with the camera seems to be rather advanced and fancy, but yeah, it doesn't seem to say anything about how to actually install the camera. That's weird. I have no idea. We don't have any more we have a couple adapters. How is this supposed to work? So we have the adapter. There's like a rubber thing going around, kind of like unscrew the end of the adapter, and is that going to make it fit? Like if we just use brute force, so that does unscrew. That feels horribly wrong. That does not feel like something we're supposed to be doing. That just unscrews the entire thing. No, that's not right. Let's not do that. This adapter does not fit in there at all. Do either of these rings? No, those rings do not fit either. Is this like... do we not have a right adapter for this? The camera was included in the kit, so I would be a bit annoyed if this wouldn't fit here, which it obviously does not. Have I ordered the wrong camera? I'm quite sure the camera was part of a kit. Does it say anything in like the manual for the actual microscope? Well, this manual is for a completely different microscope head. Do we seriously not have the right adapter for a camera? That would be a disappointment. That would be a huge disappointment. Well, can we at least slide it down one of these eyepieces? So that comes out. I don't know which diameter that is. Not that one. So we can put one of those in and shove the camera in there. Like, wow, that feels really bad actually. Is it actually the right adapter? That's super loose in there. Let's try the big one again. Nope, that definitely does not fit. This is not impressive. Why would they sell this microscope head with this camera? Oh wow, this is... that's janky. Well, let's see if we can at least get some picture out of it. Or if it's just completely wrong. So we should have... well, this is supposed to be a microscope camera, but let's just reselect it in OBS. Okay, we have something. Can we get that in focus? Can we get anything in focus? Perhaps we're mounted a bit too high. There should be a thing below here. Oh, we're at maximum magnification. That's going to make everything difficult. Hey, there we go. We have some kind of picture. Very low frame rate picture. And I can't shove my bloody camera down the right hole. Well, at least the camera works. That is performance inferior to what I was expecting. I don't know if we just crank the brightness way up. Well, that does make a difference. So let's at least look at something half interesting while we're down there. Here's a GPU. So we do have something useful. What? Can we not get that in proper focus? Can we really not get that in proper focus? Well, that is disappointing. I have the GPU lying on the table and we actually can't bring all the images mirrored. Well, this is obviously a setup issue with like the software or something. Why on earth will the driver default to mirroring the image? Or do I just have it like... Oh, no, wait, hang on, it's like 90 degrees, 180 degrees wrong? Yeah, now we're getting somewhere. Well, let's see, that's making more sense. But wow, this is horrible. Like, it can rock about. And we can't get the microscope down. Oh, well, no, hang on. I'm retarded, of course we can. I'm forgetting that I just haven't calibrated this thing at all. I'll put that down a couple of centimeters. Oh god, I'm an idiot. There we go. That's not Amscope's fault, that's my fault. Right, that's better. Now we're in focus. But like the fact that this doesn't seat properly in the holder at all, that's just annoying. But at least we have some sort of image. Which way is fast right? Did it wrong? This thing, I was like you just poke it, and now it won't die. Is it actually going to work now? Is it out of battery? It's not out of battery, it just died randomly. Sorry about that. So the chat just told me that we have no audio. And we've had no audio for a long while. Sorry. I really need to fix that bloody microphone. Sound able at 420. Okay. Well, we've had audio for a while then. Phew. Ugh. Let's have a piece of horrible cold coffee. Ugh, that was bad coffee. That's like 5 hours old. Okay. So you haven't missed much. Sorry, I've just been rambling about this bloody camera not fitting right, so let's just see what happens if we shove it on there with the adapter thing on. And that's still completely horrible. Okay, let's try it that way. I checked the battery level a moment ago, it was fine. This, there has to be something wrong with this bloody thing. Christ. I can't believe I don't notice it though. I keep looking at the sound meter. Maybe my batteries are just retarded and I'll just put this on the charger. Bloody hell, thank you for letting me know we're on out of sound all the time. Anyway, what I was saying was we found a great big focusing rack adapter for the camera lying in the box for the head. So none of this has been about Amscope being retarded, this has all been about me being retarded. I'm obviously an idiot for not looking in the box for the stuff we need, so let's see if we can't get this to work properly now. Whoa, 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 whoa. This thing is brutal. So, yeah. This is a focusing rack. It slides out in and out. Has a screw for tightening it down. And I bet this is going to somehow fit in this. Yeah, that feels like it could possibly be intended to go on there. So, let's get this thing back on. And try and undo any horrible alignment issues we've caused. This thing isn't on completely straight from a factory, actually could be. That's some calibration things, so how does this work? Which way around does this go? Does it go like so? I think it goes like so, because it doesn't fit at all the other way around. Okay. This Allen key is one size too big. There we go, so that's on. And we can adjust that up and down. There's lots of up and down motion of this. Okay. That works. So let's give you guys the big premiere live on camera. Let's see. Pop. I think it goes that way around. I think that looks a lot better. That looks a lot better. So let's just... is this... I don't think this has any mount. I don't think there's any way for us to lock the camera in place, which is going to be annoying. So is that reasonably in focus? The microscope itself is in very good focus right now, so... that looks about as good as it's going to get, but that's a bit annoying. So, what's the right way around? Let's see. So now that's completely straight with a chip in the lower right corner, so this goes... is it mirrored? Is it actually mirrored? It is mirrored. Why on earth are you mirrored? Stupid thing. Can we, like, change that? Do you? Come on. Flip horizontal. There we go. Why does the stream... okay, I think the stream is freaking out now because I have like the calibration thing done. Anyway, is that right? Yeah. That's how it's supposed to go. But we have no way of actually locking that in place. Are we supposed to just wrap tape around that? That's awful. Really? There's no way to get that to stay in place. Like, whoa, let's see how well we can use the loom of this camera. Like, that's the camera, and it just spins. That's really weird. I guess we're just supposed to wrap it in tape. Perhaps you're not supposed to use these in a very mobile setting, but no, that can't be. Am I missing something? Are there more pieces? No, that's all the pieces. Oh, here's another manual. Oh, so that's the same manual. Oh yeah, that's the same manual as we had before. I just put it back in the box. The Swede in the chat just said, for hell's sake, is it not time for the Åland people to go to bed by this time? And no, it's not. No, it's not. I got up just a couple of hours ago. We're seriously going to have to wrap our, like, €1,000 microscope in tape. That's not a problem. We've got lots of tape. Oh yes. Oh yes. We have the best tape. Pink as hell. So it's supposed to be like that way. Is this seriously supposed to be this way? Yeah, there really is no locking mechanism for it. Wow. So we'll get that perfectly in line. Although I suppose we are able to rotate the whole thing later on. That's going to work. That's pretty good. There we go. A beautiful pillar of pink duct tape. Okay, let's see how that looks. Did I completely destroy the alignment? So let's just put the chip right in the middle. These eyepieces are not a friend of mine. Like focusing thing. This is like slightly annoying to use because the rubber piece on the microscope kind of doesn't really hit my nose at any point, so it's just up to my neck to keep everything in place. But I suppose I'll have to learn to live with that. And now everything went completely out of focus. Here, let's just zoom right in so we have a super easy time focusing. Oh yeah, that's going to be completely out of focus now. This should narrow our depth of field. The camera has a much deeper depth of field than the actual eyepieces. That's curious. It's a bit difficult focusing this on the monitor because I just have a tiny little thing for OBS Studio open. How's that? The camera really has a massive depth of field even at the maximum zoom level. I guess that's about as good as it's going to get. Yeah. And how's our rotation? So that's these lines are quite straight, and they are not straight at all on the microscope, so we'll just rotate the whole thing. Oh god, now I'm rotating the whole head. So that should be horizontal, I think. Yes. There we go. And toss that down. So a couple of things to note on this is the field of view on the camera is tiny compared to the field of view on the microscope. That's probably so that you don't have to see the round circle you get on the camera, because that would just be annoying. The other part, and it's still super annoying to focus because that doesn't look to be in perfect focus anymore. I need to get OBS Studio bigger so I actually have a chance at seeing this. That looks absolutely horrifying. Focusing. I think that's as good as we're going to get it. So we will need to have the brightness cranked in order to get any kind of picture quality from the camera. So if I put it to, this is pretty much a comfortable level to use. And I know it looks pretty okay on the camera actually. That's not too bad. That's not too bad. Someone says, every time you change the depth or zoom, you will need to refocus with that thingy. Bad thing with microscopes. And no, we should not need to refocus with the camera main thingy, because this thing should track well. Like, let's just zoom right down and adjust my zoom so it looks good in the visor. So that looks good to me. And I think that looks good to you as well. Yeah. So we do, since we have the fancy, expensive simulfocal thing, we can track focus just fine between the camera and the microscope. And that looks fine to me again. That looks pretty fine to you. I think it looks a bit blurry there because the white text is clipping. It's clipping the camera sensor. So maybe if we do something that's a bit more dulled down, like the memory there. So now that's in good focus for me. Looks pretty good. Like if we try and adjust that, yeah, it's pretty much as good as it's gonna get. Oh, there, but something's not centered because I'm just touching the focus there, and it's actually moving the camera about. Weird. But if we just zoom right down on that, we can probably still. So that's perfect focus. Oh, yeah. Yeah, we have good focus on this. It's not a problem. It's absolutely fine. Absolutely fine. In fact, the camera is a lot more forgiving than the eyepieces. Because, let's see, if we turn the camera, like this is still pretty fine, and the camera that starts to get a bit fuzzy. This is just super annoying in the eyepieces. Like, this is not fine at all in the eyepieces, so that works as long as we figure out that we actually get a camera adapter in the bag. And I just completely destroyed that because I hadn't tightened it down properly. Oh well. Let's just redo that. So that's fine. Come on. Is that good? That's slightly out. I think that's as good as we're going to get it, and tighten it down properly this time. And now make sure the tape is sticking. Okay. Oh, phew. I was really nervous there for a sec when when I didn't find the camera thing. So let's move on to something a bit more interesting, because we've gone through everything we got in the box for all our money, except for this thing, and I think there's a decent chance we're literally just gonna go through this now, since I think this is a 110 volt thing. So this is rated 8 watts, I think. Is it? Well, it says 8 watts in all the literature, so I'm just going to turn the microscope off. We're not going to use that at all. And we're going to see what happens when we plug this into our 230 volt outlet. Because I paid $30 to have this converted to 230 volts. It says so right on the bill. So I will be very disappointed if this goes up in smoke. So we're going to make the little camera film the power meter, And we're gonna make the big camera film the light if we can like get this somewhere reasonable. Let's just zoom right in on that. And up the exposure. Come on, up the exposure, stupid touchscreen. Ah, this is horrible. And painful. No, what are you doing, you stupid thing? There we go. Where's our power meter? So, if this light works, it's going to show 8 watts when we plug it into the depth adapter. I think it's going to show a bloody lot more than 8 watts. So, let's get this thing front and center. So we'll just turn this on and use the big switch underneath the desk to turn this on. And let's not depth adapter it. I am so disappointed that it actually shipped one of those. So let's turn it on. Oh, hang on. No, that's drawing 68 watts. And there it went bang. That's what $30 worth of 230 volt conversion gives you. Let's take this apart and see what went wrong. Ah, Amscope, come on, I believed in you. Ah, there's a smell of gunpowder in here. Curious part was the light was not shining overly brightly. It looked absolutely fine to the naked eye. About what you'd expect an 8 watts fluorescent to look like. So let's just see the carnage. See the carnage of what the how the hell do you get this thing out? Someone says full bridge rectifier. Yeah, full bridge rectified. Ah. Come on. Oh, this thing smells horribly. Why? How can this be so difficult to get out? So when I made my order, they actually replied in an email saying, you need to have this 230 volt converted. That tube is not happy. That tube has is not going to light up again. Nice thing they actually have a proper reflector and everything. Like, this is not a bad little light. I would imagine this would be very decent to use if it hadn't drawn 68 watts and gone up in smoke. So let's see. Oh wow. That's a bunch of electronics. That is a bunch of electronics. And the switch is actually soldered in, so we're going to have to turn on our 230 volt soldering station to get that off and see what's actually gone wrong. So that's just soldered. Is that going through a hole? I don't think so. There we go, that's one of the connections. That's the other. Okay. I think this is just going to pop out now. Yep. And we have one very, very exploded capacitor. That's warm to the touch. One 10 microfarad 250 volt rated capacitor. Let's use our fancy new microscope to look at the disaster. Let's see. Oh god, this is not going well. Need a def adapter to get that powered. Let's see what we can muster. This should be reasonably good to look at. Oh god, we need to plug. The camera still is plugged in. Why is the camera not working? Why is the camera not working? OBS Studio does not get along well with devices that change around. This is completely broken. Air. We do not have a still image. Come on. Air. Oh, it's not doing that. Okay. There we go. No? Why are we not getting image? Oh no, that's the wrong thing. Damn it, hang on, I'm just being incompetent with OBS Studio here. Deactivate, activate. Okay, now we've got image. Okay. Let's see. So this is a bit too big for viewing through a microscope, but still. There you go. There's our completely destroyed 250 volt capacitor. That's what I paid $30 to have 230 volt converted. So everything else here is just a basic driver. That's just eye cancer. We don't want to use a microscope to look at that. Nope, we do not. Let's just go to this whole standard cheapo Canon camera and have a closer look at that if we can. Get the exposure right, which you need to keep manually adjusting because it sucks. So this is an electronic ballast driver, obviously not made for 230 volts. I'm curious as to what the other big cap is for. It's another 250 volts 10 microfarad. It doesn't seem to go straight to the other one. One of the leads is in parallel, so we have the negative lead going to a positive lead of the other, so these are in series somehow, but they still exploded. Oh, that's an oddity. Very simple driver. This must be some resonant thing. Oh, did this wire go up in smoke? I think that wire went completely up in smoke. That guy has seen more current than it was rated to handle. I don't think that was supposed to be white and discolored from factory. Especially not with a bit of copper poking out through it. I am disappointed. I am disappointed. I had hoped that you had done some internal modification to this Amscope, but you hadn't. You just gave me a def adapter and it exploded when I used it. RIP. RIP forever. Hey, oh well. But at least we have... a microscope now, and I think I have a thing I've intended to check out with this. Something that's been sitting on the shelf for a long time, so I'm going to go and see if I can find that. I'll be back in a sec, because the thing I'm thinking about, I got my hands on a long time ago. Long before I got a microscope at work, and long before I got this microscope. And here it is, in a very dusty box. Let's have a look. So this is a clamp meter, a rather expensive Kyoritsu Q-Snap model 2033. Let's get that of a bigger picture. There we go. So this is a 300 euro clamp meter, AC/DC rated. These are amazing. I've used one at a work site, and they're great because they have this super simple interface. You have off, amps AC, amps DC, and 2 buttons. They only do these things, and they do them very well. But this thing was damaged from bad batteries, and it has a thing which will intermittently work, but I never actually managed to get it to fire up properly. It'll always intermittently work, and I spent hours on this thing, resoldering and doing everything I possibly could to try and make it go, but it just would never work reliably. So, with the aid of a microscope, perhaps we can actually track down the issue. So, we can take a quick look at what we've got. Let's just do something like that so you can have a wider view of what I'm doing. So, let's bring the microscope in. Let's make a decent size. Something like that. Have a quick look at the PCB. Well, the completely out of focus PCB. And we're going to have to adjust that a bit, quite a bit actually. Way down. This thing is completely not ready for use, but we're using it anyway. Why is that out of focus now again? I must have messed the camera thing up. Gag. Hengi. There we go. It's going to take a while before I figure out how to use this thing properly. But yeah, the issue has been over here by the battery connector. Because this thing, when I first saw it, it was completely covered in corrosion in this end of the board. And as you may or may not be able to see, I have reflowed pretty much all of this stuff using no magnification a long time ago. But we never got it working. So I'm thinking we probably have a broken trace somewhere that's just so marginally broken that I was never able to see or measure it with a naked eye. Someone in chat says, but that's a 110 volt microscope. Are you sure it's safe to work on 240 volt products with it? No. Well, we're not about safety here. I mean, we just exploded part of my 1300 euro it's a 1300 euro microscope. We just exploded part of it. Consider what that means for safety. Where are my tweezers? I need my tweezers to poke at stuff, but my tweezers have disappeared. It's Amscope's revenge for exploding their light. Seriously, where my tweezers are? There my tweezers are. So we definitely need to kind of tune the exposure of this camera away. I've never seen my tweezers under a microscope before. That's horrible. They're full of solder and trash. Let's just poke them into the gold sponge stuff. So this battery connector is certainly not looking too happy. That's mechanically damaged, but that could have happened at any time. I don't think that's going to be our issue. Now this is a bit annoying. The center of the camera is not quite the center of my viewport. So we have a big splosh of solder there, but that's not shorting to anything. That's probably not an issue, but let's just get rid of that. While we're at it, why? It's annoying trying to see everything. See what you guys see and what I see, because that's not the same thing. Your field of view is roughly 50% of mine. So you just see what's exactly in kind of the middle, whereas I see a lot more. So now we're getting slightly into the board. I don't think that's where we want to be. I think we want to be somewhere around here. But I'm not saying anything super obvious. We can look down into the vias. So you guys can't quite see that because it's so dark. None of them look... We actually have some corrosion down in the vias. And that could cause intermittent operation if one of the vias has completely corroded through. So let's just super zoom down on one of those and have a closer look. There is corrosion in there, but none of them seem to be completely corroded through. I've filled a couple of them up with tin or solder already, just to... Oh god. Where are we? Oh right, there's an LCD there in the way. Yeah, we're gonna have to desolder the LCD in order to actually get access to any of this. And my desoldering pump is not hot yet. I was hoping there would be some really obvious broken trace in this area. This all could be, but on the other side of the board, most of this looks reasonably good. It is so much more revealing to be looking at this through the microscope though. Like, I had no idea how much dirt and crap was on this board the last time I saw it. Jeez, that thing does not look too happy. This does not look too happy. I think that's a via that I've filled with solder, but the trace has slightly lifted off the board, so that's a potential issue. Let's just put the desoldering gun on heat up, just in case we get so far as to try and fix this. I'm gonna need a knife blade to scratch this. And this knife blade is in horrible condition, so we're gonna have to snap it off. Okay, let's scratch this a bit. See if we can coax out any issues. That looks pretty good. I'm not seeing a break in that, no. No, so the battery connector is not the issue. Is that actually really out of focus? That's in focus for me. No, it's about as in focus as it gets. This camera is just not very sharp since it's just VGA. Now this battery connector actually just goes to the other side of the board. There are vias on the underside there. So that could be a potential candidate for causing issues. Oh, there's a bit of tin sploshing. Let's just get rid of that. Off you go. Now, I'm not sure. Like, I did this with no magnification, so don't judge my soldering on this. I just basically reflowed everything trying to save this thing. Because it was just so weirdly intermittent, I could never quite figure out what was causing our problems. And now we have a solder ball just sitting around. Let's get rid of that. Solder ball, go away. Off you go. I guess I'm allergic to Amscope microscopes. There's a bodge cap, factory installed. I don't think it's going to be what we're looking at here is the switch for the whole thing. I don't think it's going to be the switch. I'd like to really zoom this camera in on what we're doing over there. Let's see if we can just get this so you guys can have a slightly wider view of what I'm doing. Telemacro. Let's see if that camera is aimed at what we're looking at. So we are looking at that. Let's just get this. There we go. That's pretty good. A bit more exposure on that and we are all set and happy. That's not too bad. That's not too bad. Nice. So, where were we? Yeah, just looking at stuff. This has not been reflowed, but it looks fine. We're all the way on the other side of the board now as well. There's quite a bit of dirt and guff on this. Someone says that gunk between the two capacitors, is that a solder bridge? Oh, I don't think so. I have not seen anything I would deem a solder bridge thus far. There's the switch mechanism. It's a bit. This is actually not looking completely fine. This is rather dirty. Is that completely out of focus on the camera? Is it actually that unsharp? No. We have a focus slightly wrong on the camera, I think. That's perfectly sharp focus for me. Is it perfectly sharp focus for the camera? Yeah. No, this is just finicky. So this is all the way on the other end of the board from the battery connector where this thing had seen corrosion damage. I have a solder ball there by that capacitor, but that's not doing any harm. This is the connector that goes out to the actual current clamp. This has been soldered and resoldered a few times, so it's a bit ugly. Nothing too bad going on though. Someone says it was around 2 to 3 o'clock from the first battery terminal you looked at. We can have a look back there again. There's the battery terminal. Here are a couple of capacitors, and I am not seeing any solder bridges at all here. We have a bit of dirt, like there. That's just a couple of loose pieces of solder, nothing to worry about. I really don't think we have anything bad. That's just a lot of flux since I used some not very suitable solder to reflow all of this. Has our desoldering pump come up to heat? It has, so let's just zoom into some area where we can solder macro. Good. That's super tight on there. There we go. Now let's just desolder the LCD from this, and wow, that's entirely invisible because there's a microscope in the way. This setup is horrifying right now. Like, it is not ergonomic at all because of the oh fuck! I'm trying to throw the soldering iron everywhere. So we're going to be desoldering the LCD display there because it's covering up most of the board on one side, and that's not helping us at all. I've already had it off a long time ago, but you kind of need to have it on in order to see if the meter works. So it went back on for testing. And this is a far too big a tip for this work. That's not going to work at all. We're going to have to get a much smaller tip. And I don't remember at all where I put those tips. I got some micro tips for this not too long ago. Ah, there we go. So there's a micro tip. They look not good under a microscope, but there you go. The normal tips are just tapered all the way down, while this one has the little extra nipple on there to make it fit into tight spaces a bit easier. There. Someone says maybe you should clean the board first. We should clean the board, yeah, I agree. But since I don't have an ultrasonic cleaner, which is on the shopping list, I do suppose, that's not like priority number one. Like, I want to check the board to see if we can see anything weird going on. Since I know you can often see things in the microscope which you can't see with the naked eye. And if we can find a visual fault on this board, well, we just fix that and move on. Brand new tip. Those heat up really quickly. Well, from 0 degrees to too hot to touch. So it's not a good idea to hold on to them while you're shoving them into the iron. Someone says, what's wrong with alcohol in a toothbrush? Nothing too major, but you really can't get into all the small crevices with alcohol in a toothbrush. Ultrasonics do such just a hugely better job of that. Let's just turn this. Wait, what? This is definitely not a 0.8mm tip. I thought all my precision tips were 0.8mm. Oh well. It's better than the other one anyway. This should be able to actually... yeah. This actually works. So I'm moving the pin around a lot while desoldering. That's to keep it moving so it doesn't re-adhere to the solder pad or via while it's cooling down. If you don't move it, it'll just stay stuck basically. Okay, that should be coming off reasonably easy now. We have 2 pins that are still stuck down, 1 pin, and I'm going to have to use the soldering iron on the other one. Which one is it? That one. Okay, there we go, that's the LCD come off. Kind of, mostly. There we go. Away it goes. Now we can have a look on the other side of the board. So, what do we have? Something awful. What the hell is that? Is that some repair done by me? That looks absolutely horrifying. Yeah. Bleh. What on earth? I do not recall doing that. What on earth is that supposed to be? I don't think that's my doing. Jeez. Horrifying. These are just pins of the ASIC thing. Every single one reflowed with no magnification. Looking surprisingly decent though. I did a pretty reasonable job reflowing this with no magnification. All those years ago. Very good. Yeah, I don't think the solder joints on the ASIC are going to be an issue, but this, whatever the hell it is, we need to clean that up and have a look. Someone in chat is asking that I have the same desoldering gun. Where do you get the micro tips? I have an Aoyu A474A++, or A plus something. And I just get the official OU tips from PCBsoldering.co.uk. Keep in mind, OU tips do not fit Hackos. Where is my alcohol? There is my industrial alcohol, and I feel that's... Oh no. Oh no, I've run away with my vodka. Oh well, guess we're staying sober. So yeah, let's just clean this up a bit. Well, that complete blanking of a camera sometimes is quite annoying. We're going to need some kind of toothbrushy thing to get at that. That's starting to look less horrible now that all the flux residue is gone. But I wonder why there's a piece of wire bridging those pads. And I wonder if that via is intact. Is that via intact? It got sold on the other side. It looks pretty good though. One annoying thing about this microscope is that the zoom control compared to the focus control go in the opposite directions from to the one I have at work. Like if you zoom in on the one I have at work, it you also have to lower the focus. But if you zoom in on this one, you have to raise the focus. So I am constantly, completely confused by that. Well, let's get my tiny tip on and just fill this V up. I don't think we're going to fix this thing today. I just want to play with my fancy new microscope for a while. This tip has not been in use for a while. My golden locks are starting to get a bit dirty. But I'm not really eating solder that well anymore. Flux. My flux has run out of date. It's starting to become really hard and horrible. And yellow, but I think it still works. I have no fume extractor on this, so this is going to be a horrifying experience actually soldering something underneath this microscope. So, come on, take some solder. There we go. So is that flowing through to the other side properly? I'm not sure. That has to go through to an internal layer of a board, because that via is not going to a trace on the other side. That could be why I never figured this out, because I really did put a lot of time into this. If one of the internal layers are broken, we're basically a shit out of luck, because we do not have a schematic for this. If we had some kind of board view thingy, it would be rather easy to just see what's supposed to go where. But we don't. So we're basically just swimming in the dark. Well, this video is a good start. And I really am done doing work for tonight after soldering this. Come on, there we go. That's eating solder. Oh. I need to get a fume extractor set up for this. So that ought to be that via taken care of. No. The rest of this does look a bit dodgy. It is a lot happier on this side than the other though. Oh man, the battery connector is going straight, this is going straight into an internal layer, because you can see it doesn't go anywhere on this side. And we'll flip it over. It doesn't go anywhere. There, this is just connected to only an internal layer. So I wonder if perhaps that's the issue we're seeing. That this simply is not connecting properly to the internal layer that's providing power to everything. If we shine a light through that, can we? I think that's going to grind actually. There seems to be a grind flood layer just filling the whole board up. So we can probably find a grind somewhere and see if we have continuity. And because this is going to be the negative lead. We have two button cells going in there. One goes on there, the other one connects on the spring to the side, and the side terminal's always positive, and the end terminal's negative, so this is going to be ground. I do wonder, can we find some place which is obviously ground on this? Perhaps that via there goes to ground because we have three big capacitors in... No, they're not three in parallel, never mind. Where can we find something that's obviously ground? Can we find anything that's obviously ground? I think this might be power. I'm not sure. I'm using a light off camera to just see if I can spot any obvious grounds. Hang on. I think perhaps that via we were just soldering might be ground. Yes, I think that via is actually ground. Because if we look at where that via is connected, it's not connected anywhere on the top layer. It is connected to that weird jumper thing on the bottom layer, but nothing else. And you can see, if you shine a light through this, I can't show you since I can't fit the light underneath the microscope, but there's 4 leads going out in each direction to an internal layer, so I would wager that's supposed to be ground. So that could be one of our main ground points. I wonder if perhaps this via as well does a similar sort of thing, since that's connected nowhere on that layer, but it is going somewhere over here. So we could just jump this to there, and also jumper it to the other one, and perhaps we have a decent chance of actually getting this connected to ground. I wonder if there's a ground point on the other, like some distance away, which we could connect to, since that end of the board has suffered corrosion damage. I'm just looking at the board through the light again. I do think we might have something, and I've also found something horrible. So right here we have a huge solder splash. We want to get rid of that. Boink. That's all better now, and I think that this resistor is going to that internal ground plane as well. Now we could also, it could be that we have both an internal ground and an internal positive layer. I'm not sure how the labeling of these caps is supposed to work, in case that's actually supposed to be the positive side. In that case we do have an internal power rail as well. I wouldn't be surprised if this is a 4-layer board, but I've got some meter so we can just beep it out. A horrible cheap meter, but that's just fine. It goes beep. So this is our big resistor, and we're obviously making a connection there. So does that go to either of our power pins? That does go to ground. So I think what we could do is just jumper this all the way over to that resistor and make that our main ground point, since that's a little bit away from everything, so we're not just hooking a part of a corroded board up to another part of a corroded board and not really doing any good. So I'm just going to take some wire and jumper it over. If I can find my side cutters. So let's get some flux on our battery connector. Lots of flux that can blow into my face as I'm soldering that. If you get one of these Microscope, a fume extractor is mandatory. Like, you cannot make do without one, because else you can't breathe while working. So that's 10. I'll get a bit of solder on the wire as well. Okay, that's soldered in place. Now we just jumper that over to our other ground point over there. Snip it to length, like so, and strip that, and we'll perhaps be good to go. Okay. that looks excellent. So we'll get a bit of flux on there as well, just to make it a bit goopier. Just a tiny bit. And some fresh solder, and then we'll tack it on. I really need something to just blow the fumes away, because this I can't handle this. I cannot handle this. To have something that can power a small PC fan. Oh, no. Ah, fuck it. I'll have to just choke it for the time being. There we go. This could potentially have fixed our issue. Potentially. The main symptom this thing has experienced is an intermittent ability to power on. Or it would just simply not do anything most of the time when you flick the power switch. This is also rather horrible, so let's just clean that up with a Q-tip. Lots of rubbing and alcohol. That makes any night a good night. We have a solder bridge there, but that's just going across a tray, so that's not a problem. Why is the board discoloured there? No, hang on. Did I do something really dumb? I think I just connected the wrong terminal to a thing. I think I connected the wrong terminal. Let's desolder this and verify. If I have connected the wrong terminal, then we know that we have an internal VCC layer as well. We might as well leave that connected, but if it is the wrong terminal, then yeah, we do not want to leave that connected, because that's just going to short her battery out. And if the right terminal, and it is the negative terminal, what am I on about? It's 5:30 in the morning. I'm just not perhaps in a place where I should be when working on delicate electronics. But I'm noticing that we actually do have... I know that trace isn't going to the... never mind, I'm just being an idiot. I thought that trace going underneath everything there was going to the negative terminal, but it isn't. It is not. So this could potentially have fixed this, but I don't quite feel like resoldering the LCD, so let's see what happens if we just kind of place the LCD on there without soldering it and turning the device on. Just having it barely connected up. I need to clear out another hole for the LCD because I've flooded that with solder. So we'll just poke this poor abused LCD into those holes. and give this thing 3 volts from the lab power supply and see what it does. And my lab power supply is cranked up to 75 volts, so that would not be very productive. Let's do like 60 milliamps, 3 volts, because this runs on 2 1.5 volt coin cells. Let's get some leads going as well. One lead, 2 leads, and an extension lead, and we're good. There's a decent chance this might actually work, but I'm not holding my breath. So I think we don't have a claw connected, but that was never the issue. And I also want to verify the polarity on the coin cells, since I could be wrong, since they're alkaline and I'm not used to working with alkalines, but no, the positive side is on the side as usual. So we'll just do it like that so you guys can see something. So this is going to be positive, that's going to be negative, and this might work now. We're getting something. It seems to be intermittent. This does not seem to be working quite as it should. We did get something for just a moment there. Oh, there we go. Is that turning on reliably now? Now this thing, the last time, it would work a few times, then when I actually reassembled it, it just wouldn't go. This seems to be working reasonably well now. I recall that like just flexing the board would make it reboot, but that doesn't seem to be happening. So perhaps it's worth just putting this back together and seeing if it's going to run. But yeah, I'm not going to do that right now because I want to check it out a bit further still. So I think I'm going to leave you guys with that, since the main focus of this video was the big expensive elephant in the room. Literally a white elephant, which almost turned into disappointment. So yeah, I'm going to end this and enjoy my early Sunday morning, and gonna see you guys at some point in the future, hopefully through some very expensive optics. So make sure you enjoy yourself. Goodbye.